Rate and slope are the same thing. Let's go and write that down. Put a little star underneath rate of slope. This is a big idea in math. I mean, I can't even stress how huge this is. That's even bigger than that. The slope of any line is a rate at which the units represented by the vertical axis. I'll put a little up and down arrow just to remind you that's vertical, even though you should know that by now. Changes for every unit of the horizontal axis. What do I mean by that? Check this out. Let's see. Thinking of what you guys are into. I know Cadio's into mechanics. Miles per gallon. Let's say you had so right now underneath this, you're going to just do a quick vertical and horizontal axis. Just a quick one. Doesn't matter. It's very cheap. No Picasso drawing. Let's say the vertical axis represents miles, and the horizontal axis means gallons. Let's say we're graphing a real life situation, and the vertical axis means miles, the horizontal axis means gallons. Then if I had like say 2 points here, like say here and here, it doesn't matter. Just put 2 points. If I were to calculate the delta y, the slope, the delta y over the delta x, then it's going to be miles. In the end, it'll be some number over some other number like we just did on warm up. It'll be miles per gallon. You see, the slope ends up being the rate of the situation. And the numerator is always a delta y. In other words, whatever the y-axis means, in this case miles, and the denominator is always whatever the x-axis means, in this case gallons. Okay, so slope is rate. What if you had a machine gun? This would say bullets. What's the rate of bullets per second? Different machine guns are quicker than others. Uzi's quicker than, say, an AR-15 or something. If I were to calculate the slope here, the delta y over the delta x, again, this doesn't have to be Picasso drawings on your notes. Just quick x and y axis, put bullets in seconds. If I were to calculate the slope of any 2 points in this graph, the final slope would be bullets per second. Some number, say 5 bullets per second, 50 bullets per second on an Uzi. I don't know how many, we can look that up later. Bullets per second. So I want to make the connection now that you're Math 3 students that the rate of a situation is actually the slope. When you're in Math 1, you just knew, okay, slope, rise over run. That's all you knew about it, just rise over run or fall over run. Now, it's higher level. It's actually the rate of a situation. I'm going to give you actually 2 examples. One about chickens and waffles, and another one about burgers. I'm just in an eating mood right now. Okay, here we go. Example 1. Have you guys ever been to Roscoe's Chicken and Waffles? Leave me alone. Yes, it is. Go and write this down. Yes. Find the rate of the find the rate of change of the line passing to the points. Y represents chickens. I'll put C for chickens, and X represents waffles. I'll put W. And the 2 points, you can just draw them or just write the the coordinates on your note paper. So the first order pair is 1, 2. Second order pair is going to be 2, 4. So right now it's not even needed for you to actually draw the points, just write the coordinates down. Find the rate of change of the line passing through the points. Y represents chickens and X represents waffles. All right, so this graph, I didn't specify what the data actually means. We know it's chickens and waffles, but this could be someone eating chickens and waffles. This can be someone cooking them. It doesn't specify. That graph can be either one. We don't know. Maybe throwing away in the trash chickens and waffles. That's the rate for every one waffle thrown away in the trash, 2 chickens are thrown away in the trash. Or if it's someone's eating all this stuff, for every 1 waffle eaten, 2 chickens are eaten. That's what the order pairs mean. So right now, it doesn't matter. We're going to find the speed, the rate. How fast is someone eating chickens for every waffle? Let's find out. So let's go delta, delta. But instead of delta y, what does the y-axis mean here? Right, so I'm going to put delta c over delta w, right, instead of delta x, y over delta x. Because we're dealing now with a real situation. This is math 3 now. We got to rise above it, the less abstract, and apply the abstract to real situations. So the delta chickens over delta waffles, the change in chickens over the change in waffles, let's do it. What are the 2 values for chickens? Think of warm-up. What are the 2 values for chickens in this case? 4 and 2, huh? Okay, this is a chicken value, and this is another chicken value, the 4 and 2. Let's subtract those 2. Let's see. 4 and 2. 4 minus 2. Now remember, I used this ordered pair first, so I have to use this ordered pair first when I do the delta waffles. 2 minus 1. I think so, huh? 4 minus 2 is 2 over 1. So 2 what? What does that mean, though? Now that's 2 what? Close. You're on the right track. So what does 2 mean? 2 over 1. Someone help me. That's the slope. But 2 over 1, what does it mean in this situation of someone eating or someone throwing away chickens or someone cooking? What does it mean here? Right. So, or what's a more sophisticated way of saying a rate? In other words, if you're driving and you see that the speedometer, you don't say, you know what, I'm driving 50 miles for every hour. Yeah. Do you say like that? How fast are you driving? I was driving 50 miles for every hour. Is that how you say it? How do you say it? So now use that for here. What does that rate mean? There it is. 2 chickens per waffle. I agree. So here it is. The rate on your notes, the rate is 2 chickens per waffle. That's how we express rates. Per means for every, right? Per for every. 2 chickens for every waffle. You could write like this. Thank you for asking, because I want to get into that. You could do it this way, watch. 2 chickens. Like this. That means per. Okay? It's up to you. So what's the main lesson right now? Slope is easy. You can do that in your sleep. Calculating the slope, delta y, delta x. Now we're applying it to real situations. And you have to know how to say that slope in a rate, a real life rate, something per something, bullets per second, miles per hour, feet per second, and so on. Let's try one more. One more food example and we're done. So here, y represents burgers and x represents minutes. So burgers per minute. I was at In-N-Out last night at 12 midnight. I had a double with extra onions and tomatoes. Normal onions. My wife appreciates my breath after normal onions like that. Drop dead. She ate animal fries, I didn't. Oh, jeez. I didn't think In-N-Out was going to create a fight here. Go ahead and write this down. So instead of, slope is delta y over delta x, but we're not dealing with x and y. We're dealing with B and M, huh? We're dealing with burgers and minutes. So the slope then would be delta burgers over delta minutes instead of y over x. It's a real situation. How fast is Mungia eating these burgers? I'm hacking them down. I'm hungry. Let's see. Argument, please, just by looking at why you say it's negative. Okay, so you're just doing it in your head. That's why you think it's negative. What about this line? Look at it real quick, because this is going to be part of your table talk right now. Is this line going up from left to right or down from left to right? From left to right. It's going up. So looking at that handout I gave you during warm-up, yeah. So just off the bat, we know it's going to be a positive slope. Okay, just so you know. And if you have a negative numerator, then that means the denominator should be negative also to make it positive. Okay. Let's see. You see what I'm saying? So just because you have a negative doesn't mean it's going to be a negative slope. It could be a negative and a negative makes it a positive. Let's do it. All right. Delta Burgers. Sounds like a burger stand on Delta Burgers. Let's go into business. Make some money. Delta Burgers. You're going to cook the burgers? Should I trust this guy cooking my burgers? Oh, shoot, I forgot. I don't want to start a fight again here. Here we go. Burgers, let's do it. What numbers are my burgers? Nice. And here's my minutes. Delta Burgers. I'll use this ordered pair first. Okay, so the Delta Burgers is going to be 1 minus 2. The Delta Minutes, so again, I got to use this ordered pair first since I use that one for the Delta Burgers. The Delta Minutes is 2 minus 5. Okay, burgers, minutes. Let's simplify. Here we go. 1 minus 2 is a negative 1. 2 minus 5 is a negative 3. Okay, what's going on here? Let's see. So this is going to be a positive 1/3. Talk to me, what? Why? Well, can someone answer that for me before I answer? Well, why would it be positive? What do you mean? Okay. All right. Right. What's negative divided by negative? Positive. That's why. Negative 1 divided by negative 3 is going to be a positive 1/3. All right, so what does this mean now in this situation of me eating burgers of hungry Mr. Mungia? What the heck does this mean? 1/3. Nice. Beautifully said. Beautifully said. So this means, say it one more time. I know. Going to write this down. 1 burger per 3 minutes. So that's exactly what it means. I'm eating 1 burger for every 3 minutes. Okay? Now, what if I want to know how many burgers I'm eating per minute? What if I want to know how many burgers am I eating for every 1 minute? Because like say when we're driving and you look at the speedometer, you don't say I'm driving 50 miles per 5 hours. Okay, one more time. 1/3 of a burger per what? Okay, good. So what I want to do is, in real life, we express rates as per 1 something, per 1 hour, per 1 minute, per 1 second, it's always 1. So the denominator has to be 1. So even though this is technically right, this is actually bad manners. If we're going to express a rate, it's always got to be per 1 something. When you drive down the street, it's not, I'm driving 10 miles per 2 hours. It's per 1 hour, right? It's always per 1 something, per 1 something. So let's make this denominator into 1. So what I'll do is I'll take 1 divided by 3. I'll get my calculator out. Watch this. You can just watch me do this. You don't have to watch this. 1 divided by 3, turn it into decimal. 0.33333. So watch this. I'll round the nearest hundredth here. So on your notes, go to write good manners. Good manners is this. This changes rate. Even though 1 burger per 3 minutes is the same speed as, watch this, 0.33 burgers per minute. Per 1 minute, you see. What did I do there? I took the denominator, I made it, what's 3 divided by 3? That becomes 1. And what's 1 divided by 3? What's 0.33? You see. I reduced the fraction, making the denominator 1 by dividing the top and bottom by 3. That's what I did on my calculator. I take 1 divided by 3, so 0.33 burgers per minute. Right, this is the way, this is real life situation. We don't talk this way in real life. 1 burger per 3 minutes, if we want to know the rate. Even though that's technically right, it makes sense. 1 burger for every 3 minutes that passes. People want to know how many burgers per minute.
Will it always be per minute? Could be for every 5 minutes?
Well, here's my thing. It could be. It could be every 20 minutes. How many burgers can I eat per every 20 minutes? I can figure that out. But people are usually interested just in the basic rate. How quick were you eating that burger, Mr. Flores? So I was eating 0.33 burgers per minute. What do you mean? What would they say then for like, well, you've heard of rates before in your life, I'm sure, right? Miles per hour. No, talk to me. Or you can do it the way Miss Vega said it, 1/3 burger per minute. How much is 1/3 of a burger? We're going to chop in 3 pieces. How about like that? 3 pieces. So 1 minute I eat this. The second minute, another third. Third minute, whole burger. That's how quick I'm eating the burger. A third every minute. 0.33. Okay?